Ozone is formed in the atmosphere as a result of chemical reactions between oxides of nitrogen and volatile organic compounds such as hydrocarbons. If it is inhaled, it damages lung tissue, reduces lung function, and sensitizes the lungs to other irritants. Scientific evidence indicates that ambient levels of ozone not only affect people with impaired respiratory systems, such as asthmatics, but healthy adults and children as well. Specific effects, particularly at elevated concentrations, include eye and lung irritation. Ozone is also responsible for several $billions of agricultural crop loss in the United States every year. As displayed in the image, some of the major sources of oxides of nitrogen and volatile organic compounds include emissions from industrial facilities and electric utilities, motor vehicle exhaust, gasoline vapors, and chemical solvents. Recent epidemiological studies provide generally consistent evidence for associations of long-term ozone exposure with the development of asthma in children. Ozone has been directly linked to respiratory issues, especially in children. Because ozone is less water-soluble compared to other gases, it is able to penetrate to the small airways. There are a number of other health issues that can come about because of it, although studies are still attempting to determine exactly how big of an impact ozone exposure has on them. The chart located in the upper right hand of the screen is displaying a summary of causality determinants by exposure duration and health outcomes, while the chart below it is indicating the causality determinants for the ecological effects. As of the latest guidance from the EPA, respiratory effects are the only ones with causal or likely causal relationships, with all other negative health outcomes still only suggestive of a causal relationship. We can see here that in the 10-year period between 2006 and 2016, the entirety of the metro Atlanta area saw significant reductions in the number of days with maximum 8-hour average ozone concentration over the National Ambient Air Quality Standard. Emissions testing became standard in Georgia in 1996, 10 years before the first map. We can see that there certainly was not a reduction in the traffic here in the metro Atlanta area. It is interesting to note that while traffic has grown significantly in this period, the air quality has decreased over the 10-year time period. There could be a second factor at play here. From 2000 to 2007, there was a dry period in Georgia during which we could infer that there was a reduction in cloud cover, which would have allowed for more insulation and formation of ozone. So this, coupled with the emission standards, could be the reason behind the significant drop. As we can see, the line graph to the right depicts the 17-year trend lines for ozone days for the majority of the counties that make up the Atlanta metropolitan area. After studying the ozone level trends for the region, we determined that the overall trends for each county roughly followed the same trend. This then allowed us to narrow our focus from a wide range of counties to focus on Fulton County specifically. We can see here two charts, one comparing the Fulton County ozone numbers and the other comparing drought conditions during the same period. We can notice a slight uptick in increasing days above the standard from 2016 to the present day in ozone and PM 2.5 levels. Other studies have also shown that the levels have continued to rise. We can ask if there were gradually burn bans implemented in Atlanta during this time. It is possible that some of the spikes could be due to wildfires. We note that in 2007, the PM 2.5 spikes could possibly be linked to the Bugaboo Scrub Fire, which was one of the largest wildfires in Georgia history. It is also possible that the slight uptick in 2016 could be attributed to the wildfires seen that year in North Georgia and the Carolinas. On the left, we can see a satellite image that shows the levels of NO2 in the metro Atlanta area from March 11 to March 31 in 2019. On the right, we see another satellite image showing the level of NO2 over the metro Atlanta area from the same time period, however this current year. We can see the clear improvement of air quality from last year to this year. This could possibly be due to the pandemic not allowing for nearly as many vehicles to be on the road. Last time we saw air quality levels in Atlanta this impressive was during the 1996 Olympics. During the 1996 Olympics, the city of Atlanta implemented traffic regulations which significantly reduced privately owned vehicle operations throughout the city. They increased the public transportation by importing over 1,000 additional buses. Ground level ozone pollution has been directly linked to childhood asthma morbidity. This reduction in ground level ozone pollution during the Olympic Games provided a perfect opportunity for researchers to demonstrate how reduced ground level pollution could impact childhood asthma. During this period of reduced traffic, there was an observed 41.6% decrease in asthma acute care events for children ages 1 to 6 when compared with baseline data that was captured in the 4 weeks before the Games and the 4 weeks after the Olympic Games. Because of the reduction in traffic related to COVID-19, we could possibly see some of the same benefits to childhood asthma cases now. Due to the recent pandemic, there are currently studies being conducted which are pointing towards looking at air pollution and the impacts that COVID-19 has. Despite the short-term air quality improvements associated with decreased vehicles and air travel, the damage has unfortunately already been done to at-risk people. In a recent Harvard study, they found that there was a correlation between air pollution exposure, specifically PM 2.5, and increased mortality rates for COVID-19 cases. According to the EPA, PM 2.5 already contributes to 45,000 deaths each year. Speaking on impact, the pandemic has exposed the reality of environmental racism. Environmental racism is a concept that was created by the environmental justice movement. We can apply the term to what has been happening with COVID-19, as unfortunately individuals in a lower socioeconomic status are disproportionately affected by air pollution-related respiratory issues, specifically asthma. According to our textbook, there are a number of methods for combating air pollution. The strategies that are directly related to current ozone reduction include atmospheric dilution, reduction in quantity produced or released, and process or equipment change. One of the driving forces behind the reduction in automobile-related air pollution has been the state of California's stricter restrictions on emissions compared to the national level as regulated by the EPA. The state represents a significant market that industry leaders have two options: either manufacture cars specific to California or restrict vehicle use in California. As the cost of manufacturing California-specific models would be cost prohibitive, the auto industry has been forced to reduce emissions to the California mandated levels for all vehicles sold in the United States. This status has been threatened by the Trump administration, but thankfully 23 states are fighting back. For some strange reason, the EPHT network's ozone information stops in the year of 2016. We understand that it may take time to verify that the data is correct, but a delay of 4 years does seem excessive. Also, the timing appears suspiciously aligned with the election of the current Trump administration. The EPA released an updated study on ozone conditions in April of 2020. One of the figures is located to the right and shows that there definitely is data available from up to 2017, and yet it is still missing from the EPHT website. Reading portions of this report, as well as other recent articles, indicate that air quality in the United States has steadily been on the decline over the past several years, which further confounds this issue. In conclusion, according to the latest data available on the EPHT web portal, our trends do appear to be moving in a favorable direction. Unfortunately, there is more to the story, and recent data points to an uptick in unfavorable conditions in the Atlanta area and the United States at large. The silver lining of this pandemic has been an increase in air quality. Our hope is that post-pandemic we will see an increase in political will for improving our air quality overall.